Learning target number 4. I can identify the constant of proportionality in tables, graphs, equations, diagrams, and verbal descriptions of proportional relationships. Success criteria number 1. I will identify the proportional relationship of the measures of y and x as the constant of proportionality. Success criteria number 2. I will recognize the constant of proportionality as a unit rate in the constant of a given situation. Success criteria number 3, I will find and interpret the constant of proportionality within the context of given problems. Okay, so first we need to find out what is the constant of proportionality. Well, the constant of proportionality is the ratio of y to x. So what that means is the constant of proportionality is found by dividing the y by the x in any given situation. So what we have to do is we actually have to find the unit rate. It can be in the form of an integer, a decimal, or a fraction. If the relationship is not proportional, then there is no constant of proportionality. We don't have to worry about it. But it's always in the form of y over x. And when we talk about a relationship, if it's in the form of money and time, then it would be time per dollars. But it's always the y per the x. If we're talking about in a table, we make the ratio of y to x for all ordered pairs and simplify. The only exception is when y equals 0. And if you want proof of why you can't do that, then you can ask Siri why you can't divide by 0. If all the ratios are the same, then the relationship is proportional. If any of the ratios are different, then the relationship is not proportional. And we can see a couple of examples. The first one is if we have 3 over 1, we get 3. If we have 6 over 2, we get 3. If we have 9 over 3, we get 3. And then if we have 12 over 4, again we get 3. And we can see that they all equal 3. That means that it is proportional. And k would equal 3. In the next one, we can't form a proportion with the first one because x equals 0. So then we would form 3 over 1, which equals 3. 5 over 2, which equals not 3. So this one is not proportional. So there is no k on that one. The next one, y is negative 3 over negative 2, which equals 3 over 2. The next one we have 6 over 4, which equals 3 over 2. Next one is 12 over 8, which equals 3 over 2. 18 over 12, which when we divide by 6 on each number, we get 3 over 2. And on the next one, we get 24 over 16. When we divide by 8, we get 3 over 2. So then our k is 3 over 2. On the next one, we have negative 2 over negative 1. We can't do the next one because x equals 0. Oh, this one equals 2. Then we have 2 divided by 1, which equals 2. 4 divided by 2, which equals 2. And then we have 9 divided by 3, which equals 3. So then the next one is not proportional. When we look at a graph, the graph must be a straight line and pass through the origin. Now that part is really, really, really important to remember. That's one of the most important things to remember about a proportional relationship. It has to be a straight line and has to pass through the origin. You have to make a ratio of y to x for any ordered pair and simplify. It doesn't matter what the ordered pair is, so long as you make it for one ordered pair wherever it crosses easily, and you can make an ordered pair easily. First, let's look at each one and see if it's actually proportional, and then you can make your ordered pair for those that are. We look at the first one. It passes through the origin and it is a straight line, so we know that that one is proportional. The second one, it passes through the origin, but it's not a straight line, so it's not proportional. On the next one, it is a straight line, but it doesn't pass through the origin, so this one is not proportional. On the next one, it does pass through the origin, and it is a straight line, so we know that it is proportional. Now let's go back and find what the constant is. So on the first one, I can see that the y is 4, and the x is 2 where it crosses. So I'm going to say 4 divided by 2, because it's the y divided by the x, and that's 2. So k equals 2 on that one. On the fourth one, I can see that it crosses where the y equals -3 and where the x equals 3, and so the k equals -1. On to the equations. And on this one, this is the really important part, that it must be in the form y equals kx. And this is really important here, and then again on the next part where you get into slope-intercept form when you get into the next part in the 8th grade standards. K is the constant of proportionality. It's also the ratio of y to x. And if you want, you can put y equals kx right above this to make sure that it's in that form to check against it. And is it in that form? Yes, it's in that form. And then what is k? Well, you already have your y, you can match up your y, you can match up your x. Well, what is k? There's only one number you have left, and that's 10. So k equals 10. And the next one, you can again match up your equation. You have your x, you have your y, and then if you match up your k, so your k equals 3.2. You can't have anything else added on. If you have anything else added on, your equation isn't going to be proportional. So if I do that here, y equals kx, I can match up everything, and I've got my k, but then I've got this part right here added on. And so because of that, it is not proportional. Here, I can see that my k equals 5/3. On this one, because of all the extra stuff added on, I can see that it is not proportional. And on this one, I can see that my k equals -9.